Alright, this is part 2 of a test on set theory and probability. In this video we will do some more Venn diagrams, but we'll go ahead and do a triple Venn diagram, see if we can wrap our heads around that, among other things. Alright, so number 5. Let set G be the number of students who love the Georgia Bulldogs. Let set F be the number of students who love the Florida Gators. And let C be the number of students who love the Clemson Tigers. Okay, find the probability of being in set C and G and F. Okay, well that probability is represented by this one number here at the center. Okay, this 2 represents the students who love all 3 teams. So as far as probability, it's going to be target over total. Okay, so it's going to be 2 over, or whatever it's the total. So for the total, we need to go ahead and add up all of these numbers, including the 22. So let's figure out what that is. Alright, I counted up the numbers this way. The yellow numbers added up to 30. The blue numbers add up to 20, and the green numbers add up to 10. So that's 60 so far. But let's not forget the 22, okay, who are outside, but yet part of the survey. Okay, so that's a total. So the total is 82. Now, with that in mind, if we want the probability of C and G and F, that intersection is represented by this one number. So target over total should be 2, this 2 right here, divided by the total of 82, which reduces down to 1 out of 41, which could be written as 2.44%. Now, if we want to find the probability of the union of G and F, so the union of G and F involves all of these numbers that are in G or F, the 23, the 5, the 2, the 1, 17, the 3. If we add up these 1, 2, 3, 4, 5, 6 numbers, that's going to be our target. So target over total, these 6 numbers add up to 51. So again, the total is 82. So 51 out of 82, which does not reduce, but could be expressed as 62.20%. So that's the end of number 5. Okay, for number 6, we're supposed to determine whether or not events C and D are independent. Well, as far as calculations go, the thing that we learned about independent is events C and D will only be independent if and only if the probability of C times the probability of D is equal to the intersection. Whoops, I don't know what I'm putting in here. So probability of C and D, you know, the overlap. So we can do this calculation and see if the left side equals the right side. If it does, then they'll be independent. And I guess that's what they're sort of walking us through those steps by having us do these calculations individually and then explaining. So probability of C, first of all, see how these are already given as decimals? That means these are already percents. So the probability of C means both of these together, okay? Not just the 0.2, but with the 0.1, together that's 0.3. So that probability is 0.3. Now the probability of D is these two, okay? It's everything in circle D. So that's 0.1 plus 0.5, so that's 0.6. Okay, so that's the probability of D. Now the probability of C and D, that's the overlapping part here. So that's 0.1. So now to answer the actual question, are the events independent, we will use the formula as a test. So we will do 0.3, all right, times probability of D, so 0.6, and we'll see, does that equal, so I'll put like a question mark here, does that equal 0.1? Okay, if it does, they're independent. If it doesn't, then they're not. So let's go. So 0.3 times 0.6. I say 0.3 times 0.6. Okay, that is 0.18, not 0.1. So 0.18 does not equal 0.1. So no, they are not independent. So we could say no, and the explanation is the probability of C times the probability of D does not equal the probability of C and D. And of course we have our work here to back it up. On to number 7. Girls and boys at Rock Ridge Nature Camp had to sign up for either rock climbing or archery. The table shows which activity the boys and girls at the camp chose. Alright, boys, girls, rock climbing, archery. Here's the table. Okay, find the probability of someone being a rock climber or a boy. And I sort of already said what it represents. Okay, basically it's just saying these symbols in words. But so let's go ahead and do the calculation first. So rock climber or a boy. So here are my rock climbers. Okay, and here are my boys. Okay, so everybody that I just highlighted is included in this probability. Alright, rock climbers or boys. So I'm going to add up all three of these numbers, and that'll be my target. I'm going to need the total of this table, so I might as well. Alright, the sum of the three yellow numbers is 73. So the probability here is 73 out of 100. Alright, 100 being the total of the entire population. So obviously we're dividing by 100. So I don't know if this reduces. I don't think so. 73 over 100. Yeah, that doesn't reduce, but clearly that would be 73%. So that's the answer as far as the probability. Now, what does this probability represent? This represents the probability of choosing a rock climber or a boy. Alright, find the probability that a student choosing rock climbing given that the student is a boy. Okay, by now we're experts at this. When they say given something, we focus in on that like a laser. So given that the student is a boy, that means we're going to focus on the boy row. Okay? And furthermore, that means everything else we're going to ignore. So it's like the girls don't exist for the rest of this problem. It's only the boy row. So given a boy universe, find the probability that a student will choose rock climbing. So now our target out of total, given this universe, rock climbers, there are 34 out of a total of 50 people, right, boys. So 34 out of 50. This will reduce Minecraft. Where did that come from? Just messing up. I meant to click on this, so I forgot what I was doing. 34 out of 50. So 34 out of 50. That's 17 out of 25. which is 0.68 or 68%. Okay, yeah, awesome. Now, find the probability that a student is a girl given that the student chooses archery. Alright, again, I love it when they give us something because it makes the universe much smaller. So, given that the student chooses archery, that means we are only going to live in the archery universe. Everything else, forget about it. Alright, so we can forget about rock climbers. They do not exist for the purposes of this exercise. Alright, only archers. So, now, find the probability that a student is a girl. Well, the number that represents girls is the 27. Okay, these are my girls. So that probability is going to be 27 out of a total of 43 archers. Alright, so 27 out of 43. Now I don't think this is going to reduce. Yeah, so that's all done. But as a percent will be 62.79%. Okay, there it is. And we've reached the end of another page. So I think I'm going to stop this video here and continue the next video, the third and final part, with these other word problems. Okay, so in the last video we're going to work with a deck of cards and talk about card probability, and we're going to have to use those formulas, okay, like these formulas, and work backwards to solve some of those formulas. So a little bit of tricky word problem stuff coming up on part 3. So if that looks like something you need to know about, I will see you on part 3 of our lesson. Hold on, my daughter's coming down. Let's see what she says. You're okay? What's up?
Finished making the video.
I have not finished making the video. Why do you ask? I'm almost finished making this particular video, but this is only part 2.
Oh. Well, are there any more parts?
There's part 3.
Oh.
What's the problem?
I want to go to Cracker Barrel.
Yeah. Probably in
Wait,
like
you're not part of it?
2 hours, baby. It'll be like 2 hours. Aren't you gonna go make cookies or something?
I'm allowed to?
Talk to Nana. She had said something about making cookies.
Oh, wait. No. He's a little bit bossy sometimes.
Oh yeah? You don't want to make cookies with Nana?
No.
Even though you get to eat a couple?
You have any frosting?
Frosting for cookies?
Yeah. You know?
No, these are like chocolate chip cookies. There's not frosting cookies.
Oh. Because I like the cancer cookies with the frosting.
Cancer cookies. Yeah, we only have those at the holidays.
Oh.
She's talking about cookies that have so much frosting and food coloring and dye that they're probably carcinogenic. Alright, go ahead and, this video is getting long. Go ahead and say goodbye to the,
Goodbye.
There's the microphone over here.
Goodbye.